Okay, in this video we'll do an example for optimization problem. The example asks for find two positive numbers such that twice of the first number and the three times of the second number add up to 30 and their product is maximum. Okay, remember that always the first step is do modeling. In other words, put it in a mathematical formulation. That's the first step we have to take, but the steps to complete this modeling is first, we need to identify quantities and variable. Identify quantities and assign variables. Well, here I have two numbers. Let me call the first number, then the second number, and we are going to put a product of those two. Well, for the first one, I will assign x, for the second one, y, and for the third one, p. Okay, that's step one. But step one, we do it because we want to write the relation. So find all the relations between the variables here. When we say the relation, it means that for any property given or any relation, you have to write down one equation. For example, we know that the product of x and y is p, so that's one relation. P is equal to xy. And also there is a relation between x and y. Twice as the first one plus 3 times of the second one add up to 30. So this means that 2 times x plus 3 times y is equal to 30. Very nice. Specifically, you should remember the variable, the quantity to be maximized here is p, so to be maximized. And we need that specifically. In this stage, just write down all the equation. You see that p is variable of 2x and y. We can use the first equation and combine these two and write p as variable expression of only one variable, expression in one, let's say x. So we have to do that in step 3. Find the main equation, the equation that we will maximize. Well, how do we do that? So 2x plus 3y equals to 30. I can write this and write y as a function of x. So I take x to the other side, 30 minus 2x, divide both by 3. So we get 30 divided by 3 is 10 minus 2/3 of x. Very nice. Now I use that one and I plug it in here for y. So p as a function of x is x times 10 minus 2/3 of x. And well, that gives us what? 10x minus 2/3 of x squared. That's the function to be maximized. But the the modeling is not complete until you put all the conditions that you like well, it's possible from the problem and fix that one. So in other words, find the possible domain for the independent variable. Here's x. Well, x is going to be positive. X is positive. And that means that x is bigger than 0. Also, x and y are both of them are positive number, and 2x plus 3y equals to 30. It means that, well, the lowest value of y can be 0, and x, 2x always are going to be less than equal to 30, and that means that x is going to be less than 30. Well, here I am doing a little bit naive work here. I am saying that being positive, let's just include 0 also. And y being 0, we include, oh, sorry, this is 30 divided by 2, and that's 15. We include, so it means that the domain we are working on, so the domain on the investigation is x is in the interval 0 to 50. That's the interval. Now we are done with the modeling. We found a function and we want to find a maximum of that, and we need to do the tricks we know. So this the second thing. The second step, the first step was modeling. The second step is find the absolute max value of p. Well, okay. What is p? P is this function 10x minus 2/3 of x squared, and we are trying to find absolute max on the closed interval 0 and 15. Okay, nice. Well, what do? We have a good function, continuous function on a closed interval. Then we need to find critical points. Here it means what? So we find p prime of x equal to 0. That gives us 10x minus 4 over 3. Oh, sorry, 10. The derivative. We are trying to find the derivative. 10 minus 4 over 3x equals to 0. And then from there we have 4 over 3x is equal to 10, and that gives us x equal to 30 over 4. We can simplify this as 15 over 2. Then endpoints. These are two groups we have to check. X is 0 and x is 15. Very nice. So now we evaluate p on the given points. So p at 0. So this is the first one. P at 0. This is 10. Well, actually, we can use this formula here, which is a bit easier to compute. So it will be 0 times 10 minus 2/3 of 0. This is 0. P at 1. Sorry, P at 15. It is 15 times 10 minus 2 over 3 times 15, and this cancels with that. This gives me 5. 5 times 2 is 10. 10 minus 10, this is 15 times 0. This is also 0. How about p at 15 over 2? Endpoints and the critical points. This is 15 over 2, 10 minus 2/3 of 15 over 2. This cancels with that, this cancels with that, we get 5 there. So this is 15 over 2 times 10 minus 5, and that is 15 over 2 times 5, and that's nothing but 75 over 2. Means what? Means that the value, the product is maximum when x is 15 over 2. So the product is max at x equal to 15 over 2. We were looking for two numbers x and y which has those properties. We found x. Now we can use this property here and find y. Or actually we already found this relation here. And then from this y, go back there, y equals to 10 minus 2/3 of 15 over 2. This cancels with that, this cancels with that. You get 5 there. This is 10 minus 5, that's 5. In other words, the numbers, the two numbers which have those properties, x will be 7.5 and y would be just 5. As a summary, we did do the modeling. Modeling itself had 4 steps: identify quantities and variables, find the basic relations, and then turn it to one big main equation, and then find the domain of that. And then the second step, from this point on, we have a function and an interval. We just go ahead and find its absolute max.